Hello everybody, I'm Seamus Kelly, and along with my cameraman Jack Bulich, today we will be explaining how mass affects gravity and acceleration. We're going to experiment with wiffle ball and a baseball. Two balls with different masses. Two balls with different masses. First, you may think that mass affects acceleration and gravity. You think the baseball will drop faster than the wiffle ball, right? Let's take a closer look. Although it appears that the wiffle ball hits the ground first, it's actually due to human error. I'm a human. I'm not perfect. I drop the balls at a little bit of a different time. Wasn't that interesting? What is really going on there? Let's take a closer look.
First, let's take a look at the free body force diagrams for each ball. Each ball only has the force of gravity acting on them, and therefore only one arrow is drawn facing down. Now let's take a look at the net force equations for each diagram. For each diagram, there's only one equation in the y direction, which is Fg equals ma. Now let's try to solve each equation for acceleration. Starting off, we know that Fg equals mg. Therefore, if we plug mg in for Fg, we get mg equals ma. We can then divide by m in each equation to get g equals a. Knowing that g equals 9.8 newtons per kilogram, we can plug that in to get a equals 9.8 newtons per kilogram. Knowing that 1 newton equals 1 kilogram times meters per second squared over kilograms, we can plug that in and get a equals 9.8 meters per second squared. This holds true for each ball.
Whoa, that's a lot of math. In simple man's terms, that means that the balls are experiencing the same acceleration, and mass does not affect it. You're such a loser! I'm gonna push you off the map! And I hope you fall at a rate of 9.8 meters per second with the force of gravity and without air resistance. Sorry about that. Trying to finish up my game with a bunch of non-physicists. This is only true when air resistance is negligible. For example, this wiffle ball has holes in it. As you can tell, there will be less air resistance because the air will go right through the wiffle ball as it falls. Want to see a magic trick? Of course you don't, this is physics. Let's review. We talked about how mass affects the rate at which two balls will fall. We first thought that because the baseball was heavier, the baseball would fall faster and hit the ground first. After we tested that, you can see that the balls hit at the same time, even though there was some human error. I'm sorry about that. But once we confirmed using our math and our free body force diagrams in the force equations, we now know that they will fall at the same rate, only if air resistance is negligible. I hope all you young physicists have a great Christmas and a very, very happy New Year. Remember, don't let gravity bring you down because mass doesn't affect it.